Hello, in this video I'm going to solve a problem for you on the topic of trigonometric equations. Let us read the questions together first. Solve the following equation. Tangent x multiplied by tangent of 1 over x equals to 1. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do it correctly, the answer that you will get at the end is x equals to 1 over 4, 2n plus 1 times pi plus or minus the square root of 2n plus 1 squared times pi squared minus 16, where n is an integer, but except minus 1 and 0. Okay, so I have written the problem here on the board and we want to solve the problem. Okay, so the point of this problem is to reduce the form of this trigonometric equation into the form of equality of two tangents. Because from your studies in trigonometry, you know that if tangent of some box, whatever it is in the box, equals to tangent of a circle, whatever is inside the circle, this happens if and only if what is inside the box is equal to what is inside the circle plus, let me write everything in radians because the answer was given in radians, n times pi, where n is an integer. Okay, so if I succeed to transform this equation into equality of two tangents, then I will be able to solve the problem. Of course, you might say that what happens if I have equality of two sides? That is also possible, but I think this is more natural to think that this is possible to transform it into the equality of two tangents rather than other trigonometric functions, sine or cosine. Okay, this is one thing. Another thing that is important, I want you to have this relation. So let me remind you about this. So if you have a sine of pi over 2 minus theta, pi over 2 minus theta is the complement of theta. Yes? So this means that sine of one of them is equal to the cosine of the other one. And vice versa. Cosine of this pi over 2 minus theta is equal to sine of theta. Okay? And now let me look what happens. I want to conclude something about tangent of complement angles. If I divide sine by cosine, the same angle, so it becomes tangent of pi over 2 minus theta, but then I divide this by that one, which is cosine theta over sine theta. Okay? But cosine theta over sine theta is not the tangent, yes? It is the reciprocal of the tangent. So what I can do, I can write 1 over, instead of cosine over sine, now I write sine over cosine. But sine over cosine is just tangent. So this becomes 1 over tangent. So I get actually a very nice relation, which I hope that you agree. This is very nice relation here. This will help us to solve this problem. Why? So I realize that 1 over tangent of an angle theta, 1 over tangent of an angle, is equal to the tangent of the complement of that angle. So this is what I want to use it in this problem. Okay? Okay. Now let us go back to the problem. I divide this equation by this factor. Am I allowed to do that? I'm allowed to divide both sides of an equation by an expression. I am not allowed to do that unless it is guaranteed that that expression is not 0. But it is clearly not 0, because if tangent of 1 over x turns out to be 0, 0 multiplied by any number is 0, you will have 0 on the left and 1 on the right. This equality cannot hold. So if this is supposed to hold, I am on the safe side. This factor is not 0, this factor is not 0. Okay, so I divide, for example, both sides by this factor. If I do that, so let me just do it right away here. So I divide it by tangent 1 over x. I have to also divide the right-hand side by that factor. But of course, the left-hand side, these two factors will cancel out, and what is left for me is tangent x. On the right-hand side, I have 1 over tangent of some angle. I want to give the role of theta to this, and I want to use 1 over tangent theta. 1 over tangent theta is equal to tangent of pi over 2 minus theta. So then, instead of 1 this, I can write tangent of pi over 2 minus theta, which in this case is 1 over x. Okay? So now I actually achieved the goal. I have equality of two tangents. On the first line you see here. I give the role of the box to just x, and I give the role of this circle to this guy, and then I have equality of two tangents. So what does it mean? It means what is inside the box, x, is equal to what is inside the circle plus n times pi, where n is an integer. Okay? But don't forget, your goal of solving this equation is to find the value for x. The value of x is not found yet. Here I have x, here I have 1 over x. So this is an equation containing a fraction 1 over x. So the first thing that I do, I multiply everything by 2x. Because the first thing that I do, I want to get rid of all fractions. So if I multiply the left-hand side by 2x, it becomes 2x squared. And if I multiply this by 2x, 2 will cancel that, 2x is left, so it becomes pi x. And then this becomes minus 2. I am multiplying this by 2x, x is gone, 2 is left, so I will be having minus 2. And if I multiply 2x here, so then it becomes plus 2n pi x. Okay, but then you see that I have two terms involving with x. I can factor an x out because I hope that you understand what is going on. This is just a quadratic equation in x. So I want to use ABC formula, okay? So what I do, I will have 2x squared here. Between these two, I factor pi and x out, okay? So let me factor it in this way. I factor a pi and x out from the right-hand side. Pi and x are gone out, so 2n is left from here, and then just 1 is left from here. And then I have a minus 2 here. And then I move everything to the left. That is, of course, subjective. You can do it in any way that you like to. So this is just 2x squared. I move this term to the right, to the left, so 2n plus 1 pi x. And the other one becomes positive 2 equals to 0. But this is a simple quadratic equation, yes? And we want to solve that equation. Okay, so here, this is a quadratic equation. I want to use ABC formula. So this is my A. The whole coefficient for x is b, and this coefficient is c. Okay? So I want to solve it. X is equal to minus b, which becomes positive, that expression. And then plus or minus square root of b to power 2, which is 2n plus 1 pi squared. So this one also is squared. I want to raise this to power 2. Minus 4 times a, which is minus 8, times c, which is minus 16. And then I have to divide this expression by 2 times a, which is 4. Okay? So that's actually finished. but I want to, because I found, my goal was to find x, so I just rewrite it a little bit so that it squares with exactly what I have written in the notes. So I would write it like this. Instead of putting 4 in the denominator, I put a factor of quarter here, and then I will have this. Okay. So that's the exact expression, if we go back, that's the exact expression that you see here. But why? So far, you see, when I was talking about n, here, n is coming from the set of integers. I do not see any limitations for my n up to this point. But of course, you hopefully understand that I might have some limitations on my n, because now that n was a free parameter here, but that the same n appears under the square root sign. So if I am not lucky, might be for some choices of n, under the square root sign becomes a negative value, and then the whole expression becomes undefined. So I have to make sure that this is not the case. So if I go back to slides, so you see that the expression is exactly the same. So far, I know that n belongs to z, but this is not the correct answer. You need to understand that -1 and 0 should be somehow excluded. Why is that? Let us go back to the board. In order this to make sense, under the square root sign, which is this expression, should be non-negative. Yes? So, okay, so this means that 2n plus 1 squared, pi squared minus 16 should be non-negative. So then I move 16 to the other side, so this becomes 2n plus 1 to power 2 pi squared is greater than or equal to 16. I take the square root. Remember, when you take the square root, you have to put absolute value. So this becomes 2n plus 1. So when I take the square root from both sides of an equality, of course this is positive, I don't have any problems here. N might be negative, but 2n plus 1 to power 2 is always positive, that's also positive. But even in that case, because I have the possibility of n to be negative, I have to keep the absolute value sign, then the right-hand side becomes 4. Okay? So the absolute value of a number is greater than 4. There are two possibilities. Absolute value denotes the distance to the origin. Okay? So when you say absolute value of x is greater than or equal to 4, where can you be on the x-axis? So here is assume that this is 0, here is 4, here is minus 4. I want to have my distance to the origin equal to 4 or greater than 4. There are two places that I can be. Either here and to the right, every point here has its distance to the origin equal to 4 or more than 4. Or I can be here and to the left, because every point here, it's the distance of every point here to the origin is 4 or more than 4. Yes? So this means that this statement is equivalent to saying that either x is less than or equal to minus 4 or x is greater than or equal to 4. Okay? So I will do the same thing here. I will give the role of x to this. So this means that this inequality in its turn is equivalent to saying that 2n plus 1 pi is less than or equal to minus 4, or 2n plus 1 pi is greater than or equal to 4. So don't lose the logic. What is the logic? I am trying to restrict n if possible. Okay? So my main unknown is n actually. So what I do, I want to try to isolate n. Okay? So for example, let us go vertically now. I divide everything by pi. I move 1 to the other side. I divide everything by 2. Okay? N is isolated. I go do the same thing here in parallel. I divide by pi. I move 1 to the other side. I divide everything by 2. Okay? And now it's good to actually calculate this approximately to see what are these values. So let me just do this using GeoGebra. Okay, so I am on GeoGebra now. So I calculate that number. So it is minus 2 divided by pi. Yes, and then minus 1/2. Oh, sorry, I have to go here. Minus 1/2. And then I click on this approximation. So I get minus 1.14. Okay, so this number is minus 1.14. N should be less than or equal to minus 1.14. On the other hand, we know that n is an integer. So the possible values for n so far are these values. Is 0 acceptable? No, because I want to go on the left-hand side of this number. So the first integer on the left-hand side of this number is minus 2. Yes? So for example, if you want to visualize it, so here is 0, here is minus 1, so a little bit on the left is minus 1.14. I want, first of all, on the one hand, I want to have an integer. On the other hand, I want to be less than or equal to this number. So the first integer you see is minus 2. So this means the values acceptable for n are minus 2, minus 3, minus 4, etc., etc. Okay? But now let me go and calculate that number using GeoGebra again. So this time I have 2 over pi, and then I have minus 1/2. Yes, and I do the approximation again, I get 0.14. Yes, so this means that this number is 0.14. So n should be greater than or equal to 0.14. On the one hand, on the other hand, again, I want to have an integer. So here is 0, here is 1, here very close to this is 0.14. I want to be on the right hand side of 0.14 and I want to be an integer. So this is the first number that I hit, and the next one is 2, 3, etc. So this means that n should be on the other hand either 1, 2, 3, 4, and etc. So you see, from the whole range of possible integer values, 2 of them are missing. Minus 2, minus 3, minus 4, etc. are acceptable. On the other hand, 1, 2, 3, 4, etc. are acceptable. So there are 2 integers that are not acceptable. One of them is 0, one of them is minus 1. So this means that for this expression to make sense, n should not be equal to minus 1, should not be equal to 0. So at the end, if you want to write your solution, you need to write n belongs to z. You can write n is not equal to minus 1 or 0, or in the language of set theory, you can write the set of z minus the set containing these 2 numbers. It doesn't matter how you write it down. Okay? So that is actually the end of the solution to this problem. Okay? I hope that you enjoyed the video. Until the next video, be safe and goodbye. Thank you.